Great. For those who are joining this live stream, this is a continuation of our discussion about machine learning functions for Wolfram Language. And Etienne here is sharing, and let's get started. Where have we got to last time?
So last time, we've kind of finished talking about learned distribution, and then we talked about anomaly detection.
Right. We started talking about whether we wanted an anomaly detect function or whether it should be an anomaly detection function.
Yep. I think for now we're still on the anomaly detection side.
Okay. But with a bunch of pre-trained anomaly detectors.
Yes. Yes. They will be pre-trained. We spent some time discussing about this p-value thing.
Yes.
And in the end, we're all happy with the anomaly detection threshold, which leads to also the question of how do we call when we query this property for a given example, which, in the past would be I want the p-value. But now we're not talking about p-value threshold, but more anomaly detection threshold.
But what we discussed last time is that this thing isn't really a p-value. Is that true?
It is. It is an extension of p-value. I don't think.
Well, what do you mean an extension? Is it?
Well, p-value
like a
is
confidence interval, and then like.
No, I mean, actually, in your word, the p-value is a probability to have an event that is rarer than the current event. So, in that sense, it is a p-value, although, the definitions are not, I guess to make clear, it could be the PDF p-value.
Look, all this precision, these distributions are very floppy objects. This is hardly, given pictures of cats and dogs, we are hardly reproducing, this is the perfect Gaussian distribution of it all. Am I making sense? This is just some number, basically.
True. It's according to this distribution, what is the probability to have something more extreme? Meaning less likely in terms of PDF. But I agree, it might be, and there's p-value in other places in the system. I think might be confusing. I'm okay not to call it p-value.
Okay, but the previous thing that we had was anomaly detection threshold, which is a number that gives us at what value between 0 and 1 we consider this to be an anomaly. Is that correct?
Exactly. Which, by the way, we decided for anomaly detection threshold because it would be likely that in some future you would give that directly to class. You will get to classify because the classifier might have anomaly detector, which when triggered,
Yeah, I agree that anomaly identification threshold or just anomaly threshold.
Just anomaly threshold, yeah. One thing though that I should mention right now, because this calls for going away from the p-value, but there's a part where we might want to go back to p-value in the case of denoising. So we've been thinking of using learned distribution to do data denoising function in some sense. So the names are completely open. We just which is something. Some call it denoising, some more error correction. Basically, the idea is to learn the distribution when you have data that is not noisy, and then you use that to kind of correct the data, to denoise the data. And the idea is to climb the PDF.
Yeah, I understand. So
and
really, this function, unless we really want to be more modest, why isn't it? Can it not be called denoise? I see it's data denoise because denoise might be more like audio or something, but it probably could be used for audio.
Definitely. Actually, we might have some data denoising for
No, but what about just denoise, the function denoise?
Because this would act directly on the data. like following the same design of all the unsupervised learning function. The verb act directly on the data, and the whatever that is returns.
Yeah, I understand. But why do we have the word data in front of it?
I wanted to make it less big, denoising. I mean, it could be also unsupervised denoising. I don't know.
Well, yeah, that would be what denoise of data would do. I mean, it's an effect unsupervised in the sense that it is trying to. I mean, it's in the family of classify, predict, denoise. I mean, what's wrong with that?
Yeah, I mean, why not? One thing is that, yeah, it's unsupervised, so it doesn't assume anything about the noise. It's just, I'm learning about what normal data is, I get a new example, I make it more normal.
Yes.
So, but of course, we could imagine...
Denoise of data, it's going to assume what type of data that is, and then use its standard denoising function.
Yes.
So and, probably an option to denoise is a denoising function.
I see. Yes. To already denoise. Yes. There could be some sort of, yeah.
Although maybe that makes no sense.
Yeah, it doesn't. Yeah, if you have it, you won't.
Yeah. Well, sorry, I take that back. It should be denoise of the function, comma data, just like it's denoise of. I mean, just like it's classify of the function, comma data.
Yes. By the way, it's not entirely clear how we would act on, for example, for this one, denoise data. It's not clear at all how we would do, because again, we need to have distribution on the normal data, but we have the noise data. So there's some sort of bootstrapping that must happen there, which is a bit similar to what we do in anomaly detection.
In the case of images, we have, look, we have a bunch of sort of ordinary images of the world. So if the noising is, I don't know, photon shot noise or something in the image, we probably have a clear idea what denoising would be. Right?
Yeah.
If the noise is somebody photobombed my image, then obviously we have no idea what the noise is there.
Yes. I mean, just to remind what this function is, the idea would be to learn a denoiser from the data and then use it on the data.
Oh, I understand, but there's also a pre-learned denoiser that would be just learned on all of the images we've seen so far.
Yeah, something like similar to the built-in that we've talked about before.
Right, but as a practical matter, if we have, right, so the question is...
And I didn't know the function indeed, it's all function. And the function, and I guess in a similar, instead of denoising image, it will be more denoiser function of image that would evaluate to the denoiser function.
Why? I think it would just be denoising of image evaluates to the denoising of image evaluates to a denoiser function.
But it went the other way for learn distribution. We thought it should be learned distribution of the image that would evaluate to. But I guess both will work for sure. But what
I think we should probably have. Sense? Yeah, I see. I'm not certain. Okay, can we go back to look at anomalies again?
Yeah, we will. But just to know, we will likely, give the users a possibility to set to which until when we should stop climbing the PDF. Like you climb, and when it is similar to anomaly. It's like kind of when it's not an anomaly anymore, we figured that there's no noise. I mean, there's no error in the data anymore. So we might reuse this threshold.
Yeah, I understand.
So that's why I wanted to bring it up now. I mean,
I'm thinking
threshold as well. Huh?
What's that?
Yeah, like this would be in practice the same thing, but with different names.
Well, it's actually not a threshold. It's the wrong way around. Denoising limit.
Yeah. It's
or denoising. It's something like that. I'm not certain denoising limit is right, but it isn't a threshold, because the other way around is above this is a, whereas this is saying below this.
actually, they're both.
What's that?
Denoising bound, upper bound, bound.
Bound. Well, you could say bound. I think it's better than limit.
Yeah.
Actually, they're both. No, wait, no. The anomaly detection is below that. You say it's an anomaly.
So it's an upper bound for denoising.
For denoising,
That you cannot go, you should not go more than that.
Above that, you consider it. Above that. So your point is that in both
actually, both
cases,
of them, yeah.
Yeah, you consider it a noise or an anomaly below that value.
Exactly.
I don't think it's a threshold in either case.
Mm-hmm.
Let me think. What other functions do we have? We must have a bunch of image processing functions that have comparable things.
Yes. Let's
should we see if we could find Shadi for a minute? She would know all about this stuff.
Yeah.
Okay.
Yeah, I'll look for it.
So in paint is for, not for noise, but for pressing missing values.
And
there's probably another one.
Well, no. Look at the options for in paint. Up there. Up in the details and options.
Yep. Max iterations method.
Okay. Okay, let's wait for Shadi. And let's keep going with other pieces of this design.
Okay, so yeah, so there is this value again. I mean, this property that we should find a name.
Yeah, I understand. But let's just understand what anomaly detector. Could you scroll up a bit? So the workflow is you start off with, okay, so there are functions like delete anomalies.
Yeah.
Do we really want delete anomalies, or do we want to do something with the anomalies, like smooth them out and so on?
This would be denoising. Denoising is kind of taking an anomaly and making it non-anomalous. Is that what you mean?
Yeah, it is what I mean. Well, so what does delete anomalies mean? It means if you've got a discrete list, simply remove the elements which are anomalous. Is that correct?
Yep.
Okay.
Hello.
Okay. So delete anomalies, it's fine. Okay, so what is
Not sure if you heard her. Shadi's here.
Okay, great. We are trying to name an option for this threshold, for essentially a p-value threshold, which isn't really convincingly a p-value for a bunch of these functions, and we wanted to know what image processing functions have similar options.
Okay.
What kind of thresholdy options do you have? Do you have something which has a straight option called threshold? I don't think so.
No.
Type in threshold.
No, threshold is a function.
There's
No. Just okay.
Identify. There is a recognition threshold. Actually, I could list them, right?
We have more specific option names like mean color distance and so forth.
Yeah. Okay. What we're trying to name here is, well, okay, I want to go back. Okay, delete anomalies takes a list of data and deletes those elements which are anomalous in it, correct?
Yeah.
Okay, that one is fine. Okay, let's keep going here. So classify takes something which is considered an anomaly, and essentially that's the indeterminate threshold thing, right? Which is, it says things that are below the anomaly detection threshold.
Yeah, except that currently indeterminate threshold is, it specifically look at the probability. of the classifier, so it's not really an anomaly detector. It's just like we're not sure what it is.
Is it an option for classify?
Yes.
So let's look at it.
So it's different. Intermediate threshold is we are not sure what it is, but we still, I mean, it might still be one of the possible class. The anomaly threshold will be, we know it's not, I mean, we believe it's not part of any class that we have.
Okay. So, but it's got to be named something similar to indeterminate threshold, because that's basically,
Yes.
I mean, alternatively, we could even have a list here. I don't even know how we want to do this. I mean, so in other words, basically what's going to happen, and we probably want an automatic setting for this thing, right? Because what you're saying is, so what is this going to actually return? It's going to return indeterminate there. That's weird.
Yeah.
As opposed to, what does it return if it's not part of any class?
It's always, I mean, classify returns a class, so.
Well, okay, but what do you do if it's
indeterminate?
Right, or indeterminate, or what does it do if it thinks it's an anomaly?
Well, we thought that it could be a missing, not recognized. Actually, which would be different, because you could not recognize, but still think it's part of, it's like, oh, I don't know if it's a cat or a dog, but I'm pretty sure it's either a cat or a dog.
Exactly, which is what I supposed indeterminate threshold was supposed to be.
Yes, exactly. But not recognized is not clear in that respect. Right. So it would be, it's like a out of distribution type thing. I mean, of course, not this, but that's kind of this type of things we want to say.
Well, it's
almost like invalid input, I mean, unfamiliar input. I don't know.
Unexpected input.
Yeah.
But that's not quite right either. I mean, neither of those is very clear. So not recognized means we think it's part of the distribution, but we don't know which part.
Yeah.
And why would we ever get to that?
If you have two things that are very close to each other, let's say, well,
not resolved would be a better thing than not recognized then. Not recognized sounds much more like the if that's the case, if it's not resolved would mean the thing where it's one of them, but we don't know which one, and not recognized would be we don't think it's any of them.
Not resolved. We have to know that this thing might be used for all sort of predictions. So like predicts, that can predict a numerical value. Or
so what would it mean then?
Other thing.
When does it, I mean, so you're saying we don't know what the numerical value is.
Yeah, we're not certain enough to show a result. That's kind of
uncertain, missing uncertain, as opposed to missing not recognized.
I think that's nice, very clear.
Yeah.
Well, okay, uncertain is okay, but not recognized, meaning it's crazy, basically.
Still, we don't explain why. I mean,
but then do you want to specify threshold for being certain or completely crazy or being uncertain?
See, anomalous input is pretty weird. When you type in, I mean, it's very pompous in a sense. If you type in some random gibberish and it says anomalous input, when it just means I don't know what language this is in. I mean, it's kind of a none of the above.
There's probably a name for these things, no? Out of distribution or trying to remember what people talk about for that. I mean, there's an outlier thing. I think there's a name like a drift, something drift.
What?
I think in statistics there's a name for that when your test data, drifted significantly from the input from the training data.
Boy, it's not
I don't
surprising
remember.
the site is for sale. Anyway, never mind. Let's see. Okay, back to this. I don't think that's a good name.
Concept drift. In predictive analytics and machine learning, the concept drift means a statistical property of the target variable, which the model is trying to predict change. But this is just a target variable, like if the class prior changes, for example.
Yeah, right. Okay, so look, we've got the basic bottom line here is we've got two cases. Can we just write out the two cases that we've got?
Yep.
We've got missing, uncertain. And we've got, it really isn't any of these, right?
Yeah.
It's in the set, but okay, so that one there is, it is one of the set, but we don't know which.
Exactly.
And then the other is, it's really not in the set.
Yeah.
Missing no identification. I mean, if it was classified, it might be like missing no identification or something.
Yeah. It's because the input is anomalous. I think it's also good to, because we might say something about the input. I mean, I don't know.
Okay, but let's, okay. I don't know which missing. I mean, it's sort of out of range.
Yeah.
But that's not,
just missing anomaly, I don't know.
Well, it's an adjective, probably.
Outlier, yeah.
Look, gibberish is not an outlier. Out of band, out of, yeah, let's, I don't think you're going to learn nothing from this.
I think there's another one. There's concept drift and there's a similar thing. Oh, some concept refers to concept.
This is not going to be, it's going to be some statistics term which nobody else understands. So I just don't think it's very useful. Missing, okay, look, we've got the concept here. So let's get that stupid thing off the screen.
This scissors, it's helpful.
No. You didn't like out of distribution?
I think it's very hard to understand if you're just shown that. By the way, we've got a bunch of background noise. If we could stop, that would be great.
Yeah.
Let's see, missing. Well, not recognized is the other. See, the problem with that is unrecognizable. I mean, okay, write down unrecognizable, uncertain and unrecognizable. Do you understand? Etienne,
yeah. That was okay.
I think that's not absolutely terrible. Uncertain, unrecognizable.
Yeah, although I think in the name, it should refer to whatever, sorry, where was that? To classify. You know, this option we put, this threshold option. Like you know, if you call it anomaly threshold, then it would make sense to return anomaly. Then it knows, oh, this is it. I mean, exactly, this is unorganizable. Then the user says they don't know that they can change the anomaly threshold to, you know, because you see what I mean?
What do we have? We had another thing called recognition threshold, didn't we?
Yeah.
Could you go back to the documentation on the right?
Yeah. Recognition threshold. Yep. It's probably missing, oh, not unorganized, unidentified. But it would be nice if, you know.
That seems like it's the same concept, this recognition threshold. Doesn't it?
This one is not about the anomalies of the input. It's about.
I understand. It's about whether we consider it to be an adequate recognition, which is very similar to the question of whether.
It would also return the same, but.
Okay, so that one, missing unidentified, I mean, would be unidentified would be better than uncertain, perhaps. Okay.
No, because you don't necessarily identify when you predict a numerical value. That's why we went back on that.
Okay.
I mean,
all right.
you could make them different, but
let's go back.
I think there should be anomalous something. Yeah, go back where?
Back up to the anomaly detect stuff. So the question is, we've got these things which are essentially p-values or something related to p-values, which determine, this is for Shadi's benefit, which determine when we would consider the thing to be an anomaly, or in the case of denoising, when we would consider that the thing was no longer noise.
Yep.
Acceptance threshold. That's a nice reusable.
Acceptance, I guess it's better because what we really, the threshold is, it's a threshold of normal ones because we learn the threshold of normal.
Right. So acceptance threshold would that work for both anomaly detection?
Yeah, it seems so. And denoising, yes.
It would work for all of them. That's good.
It would. Acceptance threshold, yeah. It also makes sense. Then we can say missing, not accepted.
Yeah, why not?
It's general enough.
Potentially.
Yeah.
Look, you know what? Why don't we say missing below acceptance threshold?
Yeah. Yeah, this is clear.
Except it's not below.
It might be, huh?
1L. Yeah, it might be.
English is free, no? Contrary to French, where we have an academy.
The only problem I have with acceptance threshold next to recognition threshold is that it's very difficult to remember which function takes which. One can say image identify could take an acceptance threshold and then.
Well, perhaps it should. Perhaps we should evolve image identify to use acceptance threshold.
It could also be anomaly acceptance threshold. Yeah, but then it won't be the same.
Too long.
I think acceptance threshold is a good name that could be used for
Everything.
yeah, for image identify also.
Okay. So we evolve to that.
However, maybe we will want to both tell a classifier if it's below this, it's an anomaly, but we could also say if it's below this, denoise it. I don't know if we will put denoiser in some future in predictors. You see what I mean?
Yeah. I know what you mean.
And this would go back to anomaly threshold and denoising threshold.
Well, in that case, what I would do is say acceptance threshold. No, look. So go back again to acceptance threshold, arrow.
It can accept like two outputs, like.
Well, no, why doesn't it have an association there on the right-hand side? Acceptance threshold, association, anomaly, arrow, blah, denoising arrow, blah.
Yeah,
actually, anomaly detection. No, what it should say is acceptance threshold, anomaly detection, blah, denoising, blah. Right, that's the consistent thing to do. So what that then means is that sensible?
I think what Etienne had was better. Noise acceptance threshold rather than denoising.
Yeah, okay, fair enough. So it's acceptance threshold for noise.
Yes.
Although, wait, because it's not acceptance anymore. This is, denoise up to, like, we're actually accepting it. We just, okay, maybe it can be a stretch. It's just we don't accept it as is, so we modify it. And this one, we don't accept it, we just reject it.
Do we really think it's for real that we'll want to do denoising as part of classify? Why wouldn't we denoise first? It seems like they're different operations.
Maybe
it's like you're manipulating data.
Or maybe we are not. Maybe we are not giving any control for noise. Maybe it's not something that we.
I don't think we should. On the face of it, it seems to be it's a different and orthogonal operation.
Yeah.
Okay, so acceptance threshold then. Okay, so then let's go down and look at the other thing you wanted to do, which was the p-value.
Okay, over here. How do we call it?
Right. So what that is. Well, actually, we could just call it p-value there, because that's a more technical thing at this point.
Mm-hmm.
The acceptance threshold is an acceptance threshold for a p-value. Well, okay. What is this? This is the probability, the estimated probability that the value exceeds the one given, right?
That not the value, but that
the estimate.
Find a more extreme event, to find a less likely event. So probably to find a less likely event.
And is that exactly a p-value?
I guess so. That seems to be, but you have to do a bit of translation, but the null hypothesis would be.
Yeah, I know.
Our distribution is a probability for given anomaly that when the null is true, so when there's no anomaly, basically.
Yeah.
Statistical summary, okay, blah blah.
I hate the way statistics are set up. I hate these all this stuff about just very. It's from a different age. All right, so let's go back. I'm not a big fan of using. If we can avoid the term p-value, I think we should avoid the term p-value. So what actually is it? It is the probability based on our distribution. It's the estimated probability that this is exceeded.
So probability to sample less likely, to find, to obtain a less likely sample. If it was not an anomaly.
The ordinary probability to obtain a less likely sample, basically, from the distribution.
Yeah.
Excluding this particular thing, which is anomalous, so it's not part of the distribution.
Yeah, this is like a test. Yeah.
Distribution.
Yeah, we have a distribution that's been trained on only non-anomalous.
Yeah, which, by the way, is a little bit different from a p-value, because a p-value is you're living in the distribution.
No. I mean,
yes,
p-value, typically you have the distribution of. Yeah, okay. There's some differences, but yeah.
Okay. I mean, it's basically, I don't know. Maybe p-value is the right term.
If we have something better, I'm all for it, because I agree that now I got used to it, but
yeah, we use it a lot in our discussions.
Yeah,
kind of natural to us.
So we should call it p-value.
No, but it might confuse other people. I know that, like I spent, I had to wrap my brain as well to kind of see the
connection.
Well, let's try. Okay, let's try again. So what this is the probability of all the things that are less likely than you. What is their aggregate probability?
Yeah, it's a cumulative probability. It's CDF actually up to that.
It's a probability. Yeah.
But it's not the probability to get this particular thing. It's the CDF.
No. Yes.
Yes, it is a CDF.
Probability.
That is correct.
Yeah. I mean, we can also return something. So one issue with this p-value business is that often people will write down things like that. Like 10 minus 5, which may
Well, by the way, that would be acceptance threshold, 10 to the minus 5.
Yeah, it would be acceptance threshold, yes. Which maybe is good because it's well explainable in documentation.
I think so.
But I don't know if I don't think it's so good, but I will mention it anyway. If we take the log of the p-value,
no,
and why not put negative sign, and it can be some sort of anomaly score, and it can be 1, 2, 3, and 0 is,
Well, it would be anomaly exponent or something. It would be an anomaly.
Yeah.
So it would make it even more complex to.
Yeah, right. But we might as well have a pH value or something. Yeah. How acidic is it? I mean,
actually, that's kind of what it is.
What's that?
It's kind of what it is, right? It's a log of the concentration.
Yeah, I know. That's why I said that. Okay. And I'm sure the P is something in German for pH. That one is in English, but I'm just joking. Okay. So, okay. Boy, what is the right term for this? It's really the probability of everything less likely.
Yeah.
I don't know. I mean, p-value seems. Provisionally, let's say p-value because I don't see anything else.
Yep.
It's easy to add synonyms for these strings, right? Later on.
Yes, that's true.
Yeah, it's true.
Okay. So now that's one of the properties, access or properties for an anomaly detector. But I want to take this from the top again for a second, okay?
Okay.
So anomaly detection. I think okay. Anomaly detection takes a bunch of examples. It returns an anomaly detector function, correct?
Yes.
Okay. The alternative, which we can have, and you should fill in anomaly detector function there on the right-hand side, on just above where you're. No, you've got it there, further down, 3 lines further down.
Yeah.
You don't have it. Yes.
Yeah.
Anomaly detector function on the right-hand side.
Yes. I see. Yeah, of course. Yeah.
Okay. Okay. So this case of anomaly detection of image, giving that, is kind of a degenerate case, but it might as well work.
We could also make this one work.
I think that's more useful. The first one could work by courtesy, but I don't think it's necessary. Okay. Okay. So now we've got acceptance threshold. That's all good. We can get rid of all the other stuff there.
Yep.
Okay. You can comment out all the other stuff or whatever you want to do. Put it in gray, or I don't know how you want to do it, or delete it.
No, sorry.
Put it in outtakes or whatever else. Okay, this anomaly frequency is all irrelevant. That's all acceptance threshold, right?
No. This is different.
It's different.
Yeah. This is okay. Let me put p-value. No. This is the user. Oh, I thought I wrote it down. Yeah, exactly. That kind of estimate the rate of anomaly in the training data.
Okay, are these all supposed to be the same thing? All these different versions of that?
Yes.
Option?
Yes. It was like brainstorming about what this could be. And so typical use case, the user knows that all the data, there's no anomaly in it. So they just say, anomaly XXX goes to 0, and we don't even try to find anomalies in it. We just train on everything on a distribution, and that's the anomaly detector, which will be very useful, I think. That will be the main use, actually, of this option. But instead of doing a true-false type thing, why not making something where we can be a little bit more, and say, like the bounds are between, there's between 10% and 20% of anomaly. Okay,
so why doesn't it an estimated anomaly rate?
Estimated anomaly rate.
My suggestion.
Yeah.
Anything with range? Do you really typically specify, like in that case, you would say 0.15, right? The center of that interval. Or you could still give the interval itself.
I think you just give the interval. I mean, possibly as an interval object, but estimated anomaly rate.
And
because often people will say less than 10%, that type of thing.
Yes.
Which actually, is like 0 to 0.1 or something.
Yeah, exactly. Actually, that's something we should think more with Amir, is the mean that useful? The max is definitely useful. I mean, the max is more useful than the mean, but we don't really know how really important is.
Okay, I think max anomaly rate is a nice option, which says don't even think about the possibility that there are more than 10% anomalies. Now, could you ever return an anomaly rate above 10% if you said max anomaly rate is 10%? Or is the algorithm such that you couldn't do that?
Well, we like to handle things in a soft way, so I guess, actually, if we call it like this, probably not.
So it would be better to things would be smooth, that you would have a window around this maximum. In general, the algorithms would work better.
I don't know how I would ever know. I mean, I'm thinking of practical cases. How would I ever know it's less than 5% anomalous?
It's an estimate. I mean, you know if it's zero.
So you're saying it's useless, this anomaly frequency band?
Well, the zero case isn't useless. I mean, I think, I'm just trying to think. I mean, unless you've tagged the anomalies, how would you know? You might know in some weird cases where there's some regulatory compliance thing that says there's got to be less than some number of rat tails in the peanut butter or something, and you're fairly confident that you satisfied that, you know, FDA requirement or something. Am I making sense? And that therefore you can assume that these are all right, look. I think then if you want to, why not max estimated anomaly rate?
Well, that's a bit.
It's okay.
I mean,
it doesn't matter.
It's a max, so you can put whatever you want. You see what I mean? Like if you have 20% and you put 40%, well, that's not the end of the world.
No, I understand. But what if you put 10% and it's actually 20%? Unless the algorithm insists on, you know, I don't think it should ever return an anomaly rate above.
Yeah, I think so too. Yeah.
At least for that data, right? By the way, all right, so it's either max anomaly rate or max estimated anomaly rate, and you're arguing for max anomaly rate.
Yes.
Okay, I'm okay with that.
And
okay.
Yeah. Okay. Okay.
And if you really want a min-max, you know, you can feed it in as a two-argument thing, but I think it's going to be a really exotic case. Okay, should we move on?
I agree.
Okay, so that was anomaly detection.
Yeah.
Anomaly detection. What is that anomaly detector? No, you've got tons of stuff.
Function. Yes. Because I didn't change them all.
Okay. Fine.
And actually, all this one are okay. Multiple property. Fine.
What is decision? What's decision?
This will be if it's an anomaly or not. This is a classic things you never specify, but it's kind of the same as this.
Okay.
Just take it from classify. Like if you actually put decision as a property, it will just, you know, do the normal thing. Oops.
Look, what most people are going to expect instead of that p-value thing is probability.
Yes, but again, right, it's not the, this will be very confusing.
It's not an anomalous probability. It's not
very
the probability
confusing.
of being anomalous.
Yeah. This might be more confusing than anything, you know.
Yeah. Okay. Fair enough.
Although p-value actually means probability value, which is
of course, which is confusing as hell.
Which actually percentile is something that I think people understand, but it's weird to speak about. No. Yeah, I mean, you know, we could just multiply by 100 and just say percentile.
No.
Percentile rank, or you know,
probability. What about something that starts with probability and it's like something like, well, what about cumulative probability? Not very convincing. No, it's not that. It's the probability to exceed in some sense.
Yeah. So exceeding
no.
Exceedability probability.
Excess. No. Okay, I don't know. Let's leave it as p-value for the time being.
Yeah.
Okay. delete anomalies.
Yeah.
We understand that one. And
Mhm.
delete anomalies, if you just give it data, okay, if you give it a bunch of images, is it going to default to pre-process, to effectively use the image anomaly detector?
Well, not exactly. No, because I mean, if we follow the same principle as all these other functions, they would learn from the data and then apply it to the data itself, which doesn't mean we can have good feature extractors.
Okay, so are we going to say feature extractor, arrow, whatever, and is that all we need, or do we need an anomaly detector already, about images? So if you wanted to do it on the generic image anomaly detector, you'd say delete anomalies image, data. Is that correct? And then it would use not the one learned from that data, but instead that particular anomaly detector.
Exactly.
Okay, so delete anomalies would have its own feature extractor. Is that correct?
Actually, sorry, say again.
It would have its own feature extractor. I mean, in other words, you could give it a feature extractor option.
Yes.
Okay.
And I mean, you have to be a bit careful in this case because some feature extractor actually remove the noise and remove the anomalies. So you might find that everything is good because
okay. All right. So now
then there's we might think of having an anomaly detector option instead of this, because this will, in the same way with a feature extractor, because this could be used by classify.
Yeah, I think that would be good.
So classify, blah, 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 anomaly detector.
Yeah.
And could be both a built-in and the anomaly detector function.
And then, given the anomaly detector function, we would also have an acceptance threshold, which would normally be automatic, which would operate with that anomaly detector to determine whether, because without an anomaly detector, classify doesn't really have an acceptance threshold, does it?
No, unless we, by default, all classify, train even a simple anomaly detector, which actually I think we should.
Just in case you give just totally stupid stuff.
Yeah, and it can be a very naive one, something that trains super fast, that computes some stupid statistics about the input, that training set.
Yeah, like if you give the image identifier a single pixel,
for example,
would say, forget it.
Yeah, for example.
I have no idea what this is.
For example.
It's a Rorschach test for the computer, and actually they think the computer thinks it's a picture of a giant planet-eating ostrich. Never mind. I don't know. Could be anything.
Actually, this one could also be this. I'm not sure about anomaly detector.
That's okay. It can be both of those. There's nothing wrong with that.
Yeah.
Okay. All right. So down there in classify, acceptance threshold is simply automatic, and it only becomes active if there's an anomaly detector. Correct?
Yes.
Thinking of that being an automatic anomaly detector. Anomaly detector arrow none has no anomaly detector, and it ignores the acceptance threshold. Anomaly detector automatic might do something.
Yes.
Okay.
Okay. And so what did we?
We concluded below acceptance threshold. Uncertain.
Yeah.
We concluded it would be below acceptance threshold, and uncertain would be the other case. Missing, uncertain. Actually, it really should be indeterminate. And I don't know whether that other case where we're simply returning indeterminate is right, or whether we should have that be returning missing indeterminate.
Yeah. I think if we remove the indeterminate, I would be good to transforming into missing indeterminate, since we already have indeterminate threshold.
Yes. So the question is, do we remove the thing that's just indeterminate? I mean, the word missing is a little weird. I mean, maybe it should just return indeterminate in that case.
Yeah, we had debate about that.
I mean, we obviously decided to write a vertical bar indeterminate.
Yeah. We had debate about that because it's true it's not missing.
Right.
So me, I was kind of partisan of just keeping indeterminate since we already had it. Yeah.
Well, I think there's an argument for that. But then below acceptance threshold is more of a missing. Do we think?
I mean, unless we have some symbol that is.
No.
I'm going to go again too hard.
No. Why do that? I mean, the question is it missing? The answer is yes, it's missing because we didn't put in, we got pictures of cats and dogs, and actually there's an elephant there. Okay?
Yeah, you're right. In a sense, in the first case, we cannot figure out the result, so it's missing.
It's missing because we don't have the elephant in the room, so to speak.
It cannot even work, because the input was wrong, so we cannot even do anything.
No, but the example I gave is a reasonable example. We got cats and dogs that we've trained on, but there was actually, to put it, colloquially, there was an elephant in the room.
Yeah.
Okay. Well, I think this is not totally stupid. And I think the indeterminate, given that we've already committed to indeterminate in that other case, I think there's an argument for it just being indeterminate. Not absolutely certain of that question there. Okay, let's keep going on this design, please.
Okay, and then there would be the kind of Swiss Army knife of one shot. So it just...
What does that do?
Meaning anomalies, it just extracts the anomalies. Okay, you have the same option that we have to change, of course.
Okay, max anomaly rate. Anomaly acceptance threshold.
Exactly. I'll change that later. But okay, to be a function where you can, ask for the positions. I mean, this will be the equivalent of the first one. Just return the anomalies, or give me the normal elements, or give me both.
Normal elements sounds like some kind of normal, so-and-so's normal form. Can we not come up with a better term?
Normal positions? No.
No. Those are the elements. But the question is, it would be, I would say, anomalous elements instead of anomalies.
Yeah.
Anomalous elements, non-anomalous elements, or something. No capital A, I would think. Well, maybe it's capital A. No, maybe capital A. You know what? This isn't right, because positions, then we'd have to go to anomalous positions, blah, blah, blah.
Yes.
Just elements, anomalous. So then we're back to what you said. Positions. We can't say anomalies. We just have to say elements. Find anomalies, elements. That's kind of weird.
Yeah, I know.
Of course, that's the equivalent of just the straight one argument form.
No, the anomalies will be the straight because it's find anomalies. This will be the same as the one argument fault of delete anomalies. Like, I don't think the delete anomalies can be made the Swiss Army knife because it just delete anomalies. So it's really about find anomalies that can.
Yeah, but so non-anomalous elements is delete anomalies. So
yes.
Well, if you want to do it that way, then it will be just non-anomalies. Anomalies and non-anomalies.
Non-anomalies, yeah. Yeah, I like that.
Okay. Okay, then delete that one and delete elements down below.
And
that
then,
last example changes to non-anomalies there. Okay.
and yeah, this was the competitor finding anomalies. If instead we have anomaly detect, but
well, look, I think
they didn't follow. So the default wouldn't find or anything. We just do true false. But we could have second argument. Okay, this is just detail. You know, to ask for the positions. And
I
so,
think anomaly detect and anomaly detection are confusing if we can avoid them. I mean, anomaly detect.
It's not that useful, by the way.
What's that?
Doing anomaly detect and returning true false is not that useful.
I wouldn't have thought so. Unless you want to know how many anomalies there are. Actually, we should, in undefined anomalies, we should probably have a thing called anomaly count. Anomaly count as a property.
Mm-hmm.
Right, that Boolean vector could also be associated to a string property.
Yes. No, just I would say anomaly count.
Anomaly count. What did you say, Shadi? Which?
The thing that you're proposing for anomaly detect could be
another property.
Yeah.
So what would that be? I mean, you said Boolean, I heard.
Yeah, but I don't think that's the right term for it.
It's kind of the mask. It's kind of the.
Yes, I mean it's the thing that Pick would use. It's the
Boolean mask.
Oh gosh. Let me see. What is this? What is this? Anomaly tests? No, it's not the tests. It's the results of the tests. Well, how about anomalies vector? It's kind of weird. What is the analogous encoder, the net encoder that does this? True, false, net encoder. What's that called?
Net encoder?
Yeah. No. Go to the net encoder page.
Yeah.
Okay, now open up net encoders.
There's a Boolean encode true false.
No, that's not the right thing. Look up net decoder. What am I thinking of here? There's a much longer list. Where is that? There's a much longer list of encoders and decoders.
Like for the feature extractors, or?
Oh, yeah, that's what I'm thinking of. Okay, don't we have a thing like this there? Indicator vector. No. I mean, obscurely, it will be called an indicator vector of some kind.
There's something that returns, what is, yeah. When you do cluster, which is a clustering function that returns?
Whether something is in a cluster or not?
Clustering components.
Yeah.
No,
yeah,
clustering
that's right.
components.
Yeah, that's right. That does return those kinds of things.
It's numbered. It's label matrices that come back, or label arrays.
Integer index. I think of index. So it's kind of anomaly. Yeah.
It's not an index. Let's say Boolean mask for now. It's a Boolean vector, let's say, or Boolean list. Boolean list. Boolean list is better than Boolean mask. Sounds less mysterious, so to speak. They'll do that for now.
All right. In any case, I don't think that's the most used. It won't be the most used.
Okay, so then this next thing is deleted.
Yep. Okay, so here we actually decided, but
yep. Yeah, we decided on that. Okay, missing imputation and
missing imputation. Okay. By the way, since Shadi is here, for 12, we'll only deal with numerical and nominal data. And the reason is it's the only, place. I mean,
well actually, wait, hold on a second. There's no reason why we can't have like a chroma key thing in an image, so to speak, saying this pixel value is what we consider missing to be. Similarly, in a string, we could perfectly well say, this Unicode, this character is what we consider missing to be. A star represents missing, for example. I don't see any reason I don't see any problem with that. I think that's going to be a convenient thing to do. Anyway, even if we have some more general representation of missingness.
Yeah. So.
Okay, so what I would suggest there in terms of missing imputation is that it would be something like an image arrow, what the thing assumed to be missing is.
So you mean
image blah 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 arrow in the image in the first argument of missing imputation.
Oh, I see. So okay, so let's go to missing imputation, data missing imputer
function,
or is it just missing? Yeah.
No, it's missing imputer function.
Yeah. And you say we could have something, and then we have. It's going to be, interesting how to.
Well, okay, just write that down for now. That's like the chroma key, that's like the thing that represents. Well, missing token is what it is. It's the token that represents the missing things.
Oh, I see.
Okay. So, for example, a green screen, right, would be like missingness, or a star in a list might be like missingness.
Oh, that would solve a lot of problem indeed.
Right.
I mean, we have to do some good surgery on the image, because if you start transforming it, then it's over.
Okay, but so I'm not sure that's the right notation for this. I mean, the alternative would be the thing, an option, which means
exactly. Yeah. Yep. I was actually thinking about that.
Missing data, comma, and then missing token.
So missing.
Let's say missing token, but I'm not sure that's the right term.
Yeah. And by default, it's going to be missing.
Okay, what about calling it missing data token? Missing data, for missing data token. And then, well, by default, it might be underscore missing.
Missing. And by default, sure. That's kind of what the default is. And
you want to say that first case missing token isn't the right thing. We're missing data token.
Yeah.
I would think, probably. Okay, you said the exact same thing in each case there.
Yeah.
No. You want missing data token.
No, I know, but that's okay. It's off the table.
What's that?
The missing token is completely off the table. Missing data. Don't we have? Wait, that seems like something missing behavior. I mean, we have.
Just start missing.
Yeah, exactly. All right, it's missing. Missing behavior.
Put a star
missing
before
data method. Sorry, before as well.
Yeah.
Contains missing data. So let's look. Oops. What do I do?
No, missing behavior is something different. That's what to do if you see a missing thing. This is a new idea.
Yeah, missing data method is
No, it's again that's similar to missing data. What missing behavior? What the heck is missing behavior as opposed to missing data method?
It's an option to temporal data, another function.
Yeah, that's a well, okay. So look up missing behavior.
There's an option to query and related function specify. I think we're interpreting the
This is
of the
tallyism.
How did you call the cowboy of design?
Yes, right.
Design cowboy.
I'm not really thrilled about this thing, this missing behavior thing. But in any case, it's not relevant to this. This is missing data token, I think, is probably the most reasonable term for it. It's fairly clear what it means.
The only thing is that for images, you won't be saying RGB color 100. You want a range of some sort. So it's not really a token, it's a range of values. Perhaps as well for data, right?
Possibly.
I mean, why would it be a range?
Like in that chroma key example Stephen is giving.
You wouldn't want to give a range. You would give a specific value.
I guess
you would probably map a range of values onto one specific chroma key value. That's a more stable and secure thing to do, I think.
I guess that would be two-step. First, whatever you think is missing, you paint it.
Right.
And then...
but I mean, look, you can do something. Well, I'm not sure you'd specify a range of colors. I mean, it's we don't really have a way to say this region of the chromaticity diagram.
We're proposing a color neighborhood object, which is just a wrapper that specifies with what color distance around what color with what. Well,
in that case, you're radius. In good shape here. Then missing data token could be color neighborhood of blah blah blah.
Okay, but I'm wondering if the token is still the right name for the option.
Seems like a bit of a extreme case.
Which, the color case?
Yeah. I mean, in general, we just say in this expression, and it's for you to do the preprocessing and
see, the problem is I like the term missing data. Well, okay, write down another possibility, missing data indicator.
Yeah. Not bad.
It might be better than token. Might be less technical than token.
By the way, an alternative would be a sort of wrapper
around the data.
Around the data. Yeah, so like, missing data and indicator.
I don't think that's necessary. And I think we would expect then a lot of other functions to work on that.
Yeah.
I think. I mean, you just leave that in there. Leave that in there as a note. Okay. Wrapper idea.
Yeah.
Okay.
Okay, then we have some methods. Great.
What the heck is most likely?
Hey, that's an unnamed option. Unnamed option to say, so basically missing imputation will again learn the distribution of the data. Then you kind of have two choices. I mean, possibly more, I guess, but could define a family or I don't know.
This is going to wind up being in the method option. This whole thing about what you fill it in with.
That's kind of what I was thinking.
Because I think most of the time what you fill it in with is the most likely thing to be there. That's what you want to do.
I disagree with that.
Really?
Most likely is a very dangerous thing. Yes. Because, let's say you're in numerical space and the most likely you have a little Dirac but then you have a big, a big mountain somewhere else.
I see.
it makes
Well,
more
I mean,
sense
the most
to
likely
sample in the
in
month.
context, right? The most likely thing to be there. Look, I mean, if you've got a scratch on a photograph and it's a scratch in front of a piece of grass or something, it's most likely to be green. If it's a scratch in front of the
Sure.
sky,
I mean,
it's most likely to be blue.
the sample will. Okay. What I mean by most likely is like the mode. I mean, even if it's a sample, it will always put a piece of grass. Also, on a practical point of view, it's going to be better for us to return sample than to try to optimize and find.
Well, okay. So the argument would
mode.
be this. If you've got a scratch across the piece of grass, across the area of grass, in the most likely model, probably that whole scratch is filled with the same color.
Yeah, and in the likely, so this is the likely and the most likely in a way, but because in the sample case it will work as well.
I think we need to see some examples. I think it should be initially in the method option, and maybe it gets promoted.
Okay. Issue with method option is we also want to specify the distribution method. So that would mean, we did that for active classification where you want to, but what should be the default when you just say method?
Method to what?
When you just, method without an association.
I don't know. I don't care. We don't have to. It doesn't have to work. It's up to you. I mean, we could have a few string names where they work and they bank switch some things, or we could just not have it work.
Yeah, I think by default it should be the distribution method, and I don't know.
Fine. Here, let's just keep going.
Okay.
I have to go in a moment. So
okay. So then you use a missing imputer function. Okay, right. There's not much. And you have the same option here that you can change. Oh, that's okay. That could have that would be method then. And missing input will be the one shot. Get data, imputed data. Simple.
Wait a minute. Wait. Why isn't that? Okay. All right. I guess that's right.
And actually, I was going back to the representation of missing data, but we already discussed that. Okay, that's all for missing imputation.
Okay, and let's quickly discuss data generate, whatever that is, data synthesize.
Yeah, so learn from the data and then resample from the learned distribution. And and since it knows it's just about generation, it will pick distributions that are good at generating. And who cares if they can compute the PDF or impute missing values or denoise or whatever. And so, that
I don't like the name. I mean, first of all, I think it should be synthesizer, not generator. Generator is just way too general and whatever.
Yep. Amir will like it. He suggested this.
But it doesn't get across the idea that it's from learned. It's like if you're writing a biomedical paper and you just want to fake all your data, use this function. Why on earth is it giving a data synthesize function? Why doesn't it just generate the damn data?
Okay, so in that case,
yeah, that's what it should do, in my view.
Yes.
Data synthesize.
Exactly.
Just return. Just like.
Yeah.
I mean, maybe there's. Listen. Maybe there's a different version of this. Maybe it should be. You know what? It should have the word random in it.
Random variator.
Or random data. That's what it kind of is. You know, we've got random word, we've got random color, we've got random this, we've got random synthesized data. Try that. Just write down random synthesized data. Synthesized data. That's what this really is. I mean, this is a very bizarre operation. To be honest, this is a very, very, very bizarre operation. Actually, random synthesize, I think, would be a good name. Because what it's going to do, if you say random synthesize of data, comma 5, it's going to generate 5 randomly synthesized things that are sort of related to that data.
Mm-hmm.
I mean, random synthesize of image, comma 5, what the heck is it going to give you pictures of? Cats?
I mean, if you just put an image, you would say there's not enough data.
No, I know, but if you say quotes image.
Oh, okay, quote image.
It's going to give you probably pictures of cats.
Yes.
I mean, it's just a very weird thing. I mean, random synthesize of word, for example, right, would probably give you synthesized English words, which would be cool, right?
Yeah.
I think random synthesize is the right name. I think it's a good name for this.
And you can have name, and you can have, I think we can go crazy there.
Yeah, you could do all kinds of things. Right. I mean, but this is a totally weird function, right? It's a very amusing demo function. It'll be useful for generating examples. The case where you give it real chunks of data will be quite useful.
Yes, exactly. When you give real, I mean, yeah, definitely.
I like this, and I like the name. Random synthesize is the right name, because there's a lot of randomness in it. You don't want, it's going to be different every time unless you randomly seed it the same and so on.
And random synthesizer function.
Why are we doing that? No, there's no.
Oh, yes.
Why are we doing that?
Because no. We need to have something that you can synthesize on demand. Like, you don't want to retrain each time. It might be something.
You need a synthesizer function.
Maybe then call it random synthesizer, so that still the first one arc form gives you one sample back. So random synthesizer gives you the random synthesizer function.
That's pretty weird. Because random word just gives you a random. No, don't do that.
Yeah.
No, but I'm saying what Etienne has written there, random synthesize of data gives you the function back.
Yeah.
But probably most wanted case is random synthesized data gives you one sample back. No?
I would think so.
Oh, yeah.
That's just one example, EX.
Well, the other possibility, I mean, I have to say, I would be much
function, like we could put property stuff that would kind of compete with a number, but it's possible.
Yeah, it's possible. But I think you should write the first one, random synthesize from data with single example there, just as a single example there. Now, you know, look, in a perfect world, we would just use some kind of weak hashing thing to simply store. If you give the exact same data again.
No. You want to export this. You want to put that on the cloud. You want to,
right, well, I don't like this comma function thing. I don't think that's going to work.
But it's very important to have it.
No, I understand that. I understand. I don't think it's going to work with the comma function thing. It's not going to work, right? It's
Why not?
Because we've used it differently in a million different ways.
Or we go back to the synthesization, and this returns.
That is not an English word. It will be synthesis.
Why not synthesizer? Synthesizer? Random synthesizer?
Well, are you proposing that random synthesizer
returns a random synthesizer function?
Yep.
It's good, isn't it?
Bah.
Or can just return the random synthesizer object if you don't want 3 of them.
Wait. What are you proposing here?
Random synthesize. So random synthesize is settled. Random synthesizer can return a random synthesizer object or a random synthesizer function object, either one of those. We have objects that are both constructor and the object itself. Like
No, I understand. But we're just proposing that random synthesizer returns, just sits there as a random synthesizer, which can be fed in as a first argument to random synthesize. It's probably okay. I mean, it could also be fed in as an argument to random variate.
But this is going away from the design of the other machine learning functions. And especially the unsupervised learning follow all this procedure, like the verb is doing it directly, and the whatever else is producing the functions. That would make sense. We just decided, actually, we had it in two functions before, but then we decided to kind of merge them because we realized, I don't know.
For now, let's consider this okay. Let's try it. I mean, this function may be so bonkers that we feel differently about it.
Yeah.
I mean, it may be, you know, we may,
so random
to make a stupid pun, we may get catty about it. Never mind.
Okay, so this would be the, oh, yes. And then the synthesizer would be used kind of like that.
I guess, yeah. The of no arguments is a, is equivalent to 1 there.
Sorry?
No, the of no arguments form.
Yeah,
of random synthesizer equivalent.
Not equivalent because the 1 would have a.
Oh yeah, a list price. Yep. Okay, I agree. By the way, random variate of a random.
Sure.
Synthesizer function should presumably work.
Sure. Definitely.
Okay. Okay. I should probably go because I'm supposed to do some other meeting here.
Yeah, I think we're done actually. I mean, yeah,
this is great. Okay. How long until we can get all this stuff sort of in the system? Doesn't look too difficult. It looks largely cosmetic, what we've talked about here.
Yeah. I mean, the big thing is learn distribution,
right?
Which is on its way. I mean, we'll have something no matter what. Now we're going to try to push it so it's as finished as possible for.
Good.
I mean,
I want to see what random synthesize does and whether it's all cats.
And yeah.
I mean,
that would be a separate project to train this built-in. Basically,
good synthesizers for images, especially, it needs a lot of training for each special cases.
Well, I don't know what the special. I mean, look, just saying a random image is a pretty weird thing. Honestly, I think more. It's like almost like give me a random Flickr photograph or something. Okay.
All right.
Well, looks great. All right. I think that's it. And let's wrap it up. Thanks to folks on the live stream. And see you all later.